Good afternoon and welcome to Module 11, Learning Objective 1.6, where we're going to calculate velocity and take a look at the quantity theory of money, but instead do it in equation form. So when we look at velocity, velocity is the speed with which money changes hands. And the question becomes over what period of time. If we look at nominal GDP, we normally measure that quarterly. Price level, that's on a monthly basis, so it kind of depends on which that we're using. It might be monthly or it might be quarterly. We have the money supply, and the velocity formula basically says that we look at nominal GDP, which is just the price level times real GDP, divided by the money supply will give us velocity. So here's an example. If real GDP would be 3,000 pizzas, our price level is $10. So that means that our nominal GDP would be equal to, let me see if I can get this out of here. Okay. Nominal GDP would be equal to 30,000. Money supply is 10,000, so velocity would be equal to 3. And that means the average dollar was used in 3 transactions. Here's another example. So let's say that we have here's our good corn. The economy has enough land, labor, and capital to produce 800 bushels of corn. Velocity is constant. In 2008, the money supply was 2,000. The price was $5 a bushel. Compute nominal GDP and velocity in 2008. So let's go ahead and minimize this and do that. Okay, so let's do that. Let's see here. There we go. So I'm going to go ahead and minimize that. So using the formula that velocity is equal to the nominal GDP, price times real GDP divided by the money supply. So price would be $5 a bushel times 800 bushels of corn divided by the money supply of 2,000. That gives us a velocity of 4,000 divided by 2,000. So our velocity would be equal to 2. So the average dollar was used in 2 transactions. Now, just again kind of double checking. We can use the formula for velocity and rearrange the equations algebraically if we set velocity over 1, cross multiply, and we end up then with the money supply times velocity is equal to nominal GDP. And this is our quantity equation. Here the idea of mathematics and that both sides of the equation have to be equal becomes pretty important. Velocity itself is relatively constant. Price level could fluctuate, and if we think about that idea of real GDP should grow at about 3%, then what must have to happen is either we have to have a 3% corresponding decrease in inflation, or the money supply must have to increase by 3%. So some inflation is going to have to happen when the money supply increases. That's going to lead to an increase in the price level. So in terms of debt and some of the things we've talked about in the course, this becomes kind of an interesting equation to evaluate those things. Okay, so again, when we take a look, the idea here is that we have to make sure that both sides of this equation is equal. And so we're going to look at an example here in just a moment. Okay, in this particular example, we have enough land, labor, and capital to produce 800 bushels of corn. Velocity is constant. Money supply is 2,000. Price level is $5 a bushel. And then the Fed increases the money supply by 5% to 2,100. We need to compute nominal GDP and price, and then the inflation rate, and then suppose technological progress increases GDP. So let's go ahead and minimize this and go ahead and work out this particular problem. Okay, in this problem, basically we're going to use the quantity theory of money equation. So money supply times velocity is equal to the price level times real GDP. So we have the money supply is 2,000, velocity is 2, and our price level is $5 a bushel, and our real GDP is 2,000. Then we have scenario A, and scenario A basically says the money supply increases by 5% to 2100. We still hold velocity constant at 2, so that now gives us a new answer of 4200. That also must mean then that nominal GDP becomes 4200. So we know that P times Y is going to equal 4200. Okay, and if we take P times Y and we divide that by Y, we're going to be left with P. So we divide that by 2100, and then we're left with $5.25. If we want to look at how this has changed then, for our inflation rate, we have $5.25 minus $5 over $5, and that equals 5%. So we can say then that the price level has changed excuse me, by 5%, which if you notice is the same as the change in the money supply, just showing that those two sides of the equation must be equal. Second part of this says suppose technological progress and causes GDP to increase to 824, or a 3% increase. So if that happens, then we can say, okay, money supply times velocity equals price times real GDP. So if we say that the Fed increases the money supply by 5% over here, and the inflation rate or GDP increases 3% over here, then what must the price level have been? An increase of 2%. So we can kind of logic these out as well. So again, just kind of checking our results, and we see that we had previously. Okay, the Fisher effect is the other idea that I talked to you just briefly about, and that is that real variables don't change, and this applies particularly to the interest rate. So anytime you have an inflation component, the only thing that changes is the nominal interest rate. And this is important for tax implications, because what would happen is if you had, we are charged or taxed based upon the nominal rate that we earn. So here's an example. If we have a, let's say that we have inflation is 0% and the real rate of interest is 10%. That means then that our nominal interest rate is 10%. Okay? And we're taxed then on that 10% earnings. But what's interesting is that let's say the real rate is still 10%, but now the inflation rate is 10%. What happens then is we're now taxed on the 20%, but we really haven't earned any more because the real rate of interest is still that 10%. So what happens is we're taxed at a higher rate, and our after-tax real interest rate is lower when inflation is higher, and that's the Fisher effect. And again, remember that inflation only affects nominal things. And because interest rates are expressed in nominal values, then that must mean that inflation affects nominal interest rates. Okay, so again, money's neutral in the long run. But when we take a look at inflation, it doesn't affect the real interest rate. But it does affect the nominal interest rate. And so again, just remember, nominal things are affected by inflation. More so that taxes increase with inflation because we are earning, well, the nominal interest rate increases with inflation, and so the tax rate that we pay, which is based upon the nominal interest rate, likewise increases with inflationary increases. Thanks.